Hello, everyone. It's nice to see you all here today. Today, I'm excited to be talking about natural programming, something we've been working on over the past couple of months. And let's get started. So traditionally, programming has been about a developer writing and understanding the programming language, and then machines understanding and executing it. But then Donald Knuth in the 80s proposed literate programming, where he said, let's change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer what to do, let's concentrate on explaining to human beings what we want a computer to do. So this is not necessarily about comments and API docs in the code, but instead a different approach to writing code, where in a way that's human readable and understandable, intertwining natural language explanations within the code itself. But the natural language bit is still for humans. So this is an example I took again from Knuth. So if you look at maybe like the middle area, there's instead of the code, it says print a greeting, print the date and time. And then below you have the actual code for print a greeting. So when you look at the actual program, it's a mix of both natural language and code. And then there's two separate actions that happen. It's tangling and weaving to build the source code out of it and also to build the documentation out of it. So literate programming is where the developer writes and understands obviously both natural language and programming language, and the natural language describes the programming language. The machine, though, still understands and executes the programming language. And now, Andrej Karpathy has said the hottest new programming language is English. And this is not just one quote, it's not just a quote from him, but it has come to be a common sentiment across the programming world. So with the emergence of and advances in generative AI, LLMs, and copilots, the use of natural language in programming has changed significantly. And it's not just at development time. We're seeing this being integrated at runtime with calls to LLMs within the business logic. So natural language is now a most significant part of programming and coding artifacts. And it actually has encouraged increased participation in programming and software development. And it's not necessarily restricted just to developers. Now we're seeing more and more non-technical users also being able to at least get started with their projects and then move on from there. So with natural programming, what we are seeing, what we envision is, what we've come to realize is that there's an evolution of programming where the process of programming is one of co-creation with computers, where both humans and machine express intent and actions in both natural language and in programming language. So now this diagram changes a bit. Now we have business users also coming into the picture, non-technical users maybe, who write and understand natural language, which could then translate into the programming language. We have developers who continue to write both natural language and programming language. And then the machines now write, understand, and execute natural language and programming language. So this is what we're calling natural programming. So we have natural language and programming language coming together to create natural programming. So before we move forward, obviously natural language is ambiguous. Programming language is not. There's so many things that obviously make sense to still write in a programming language. And we're not suggesting that we replace code entirely with natural language. What we're suggesting instead is that with this increased use of natural language in the programming process in code, to leverage natural language where it can enable new functionality, and also to simplify integrating natural language into programming logic. So it's more of a blend of natural language and programming language to maximize value rather than one replacing the other. So we also have a reference implementation in Ballerina for this. Obviously, most of what we are proposing, we expect to be able to apply to many programming languages, most programming languages. But we worked on a reference implementation in Ballerina. Ballerina is an open source cloud native programming language that's optimized for integration. And it's been developed by WSO2. So we have people who've worked on the language since day one who are also giving their input and pitching their input into this. So we see both angles, both the AI domain from the AI domain and also the programming language domain, to see how we can make this all more natural. So we've thought of natural programming in the software development process and code in 3 distinct stages. So the development time aspects, and then compile time and runtime. So we'll walk through these three separately. So starting off with development time. So the traditional software development process, so there's business requirements that generally get translated into technical implementation documents. That's usually by a business analyst or a technical user, and then that gets implemented in the project. So what actually goes in the project is usually, or not always, but sometimes the technical implementation documentation, and then the actual project implementation. So what we are proposing with natural programming, one part of it, is bringing the requirements into the project. So now that we are able to express intent in natural language, we are able to bring the requirements into the project and thereby bridge the gap between the business users and the implementation by making the requirements be part of the project. And these requirements can then be used to generate code, generate tests, and most importantly, check for drift between requirements and the implementation. So let's go look at this based on this simple scenario. So assume this is a requirement specification for a claim management platform. And users, employees of an organization should be able to submit claims for expenses. And if it's within a predefined limit, it gets approved automatically. If it's not, an email needs to be sent out to both the user and the finance team saying there's a claim pending approval. There's also get the status of the claim. The user should be able to check the claim status, but we'll not go into that much. So this is VS Code with Ballerina installed. So here with Ballerina, with natural programming, we brought in a new directory. So that's the project is aware of this natural programming directory and the fact that the requirements go in there. So we can also add it via the Copilot chat, but I already have it added here. And when we have that, we have WSO2 Copilot command, natural programming, where you can either generate the code, generate tests, or check drift between code and documentation, which I'll walk through later on. So code generation is kind of very similar to code generation with a Copilot, but here the distinction is that it's aware that the requirements might be at a higher level, bit of a higher level, and that there would generally be developer input too. So it also encourages proper API documentation because now we have a bit more emphasis on having the natural language and it being in sync with the code. So now it also encourages proper API documentation. We also support test generation. So we generate tests based on the requirements against the implementation. So traditionally, the tests are generated against the implementation. But if, to start with, the implementation had already deviated from the requirements, the tests aren't going to help us really identify that there's been a deviation there. So this proposes taking the requirement specification and just the APIs or like the interfaces from the implementation and generating tests against the two. It is in some ways a form of user acceptance testing, but it's not entirely that because user acceptance testing is generally at a more higher level and there's flows associated with it. And we believe these tests will actually complement both user acceptance testing and also the test written or generated by the developer. Then we have drift check. Drift check is basically checking for drift between the business requirements, the documentation, and the implementation. So again, backed by an LLM, it runs periodically in the background if enabled, or it can run on demand. So what it does is whenever there's a change, periodically it checks to see if the implementation has deviated from what the requirements specified. It also suggests changes to the code and or the documentation to remove or try and minimize drift. Again, this also encourages proper API and project documentation and makes code easier to understand and evolve while staying in sync with the requirements because we know that the check is running for us. So this is an example of the same claim management system. I said the email needs to be sent out to both the finance team and the user. But in this case, the email is sent out only to the user. And here we have this diagnostic that says the requirement specifies that when a claim exceeds the limit, email should be sent to both user and finance team. However, the code only sends the email to the user. So with this, you also see the code action. So you can click on that, and that will give you the option to update the code to match the documentation. So in cases where the other way around makes sense, you will get all that suggestion also. So you can click on that, and then you'll get a suggestion to actually fix the code. The user can review and approve the change to minimize the drift. So a common problem with natural language artifact, like natural language in code, even if you take comments and API docs, one of the main issues is that they are kind of not as prominent or not as first class as the code itself. So it tends to be an afterthought. And then more the chances that it deviates from what the code actually does. So with drift check, we also check for those deviations. So we can make sure that not only our requirements and the code is in sync, but also that the code and the documentation, code and the comments are also in sync. So another thing we've tried to do at development time is preserving the user intention. So with the use of copilots for code generation, we often have an interactive, iterative process where the user goes back and forth with prompts to try and generate the code that they need. But once the code is generated, more often than not, these prompts are discarded. But still, there can be some important contextual information that was in the prompts that were specified by the user. So what we're trying to do is to see if we can preserve these prompts also in some form, so that it would be helpful to figure out how we arrived at this final implementation. So with natural programming, we preserve a summary of the user intentions via prompts that led to a specific version of the code wherever the code is AI generated. And this is added also in the natural programming folder that I showed. So it's added in a separate file. And it's not a history of user interactions, but it is an effective summary of it. So for example, let's take the claim management implementation again, but assume the implementation was generated maintaining the claim data in memory and sending 2 separate emails to the finance team and the user. So now the user, assume, interacted with the copilot to say, use MySQL as the database. And then we say, can we have 2 tables in the database for claims and total claims against the user ID, have total claims be updated via database trigger. And then send a single email to both the employee and the finance team, and then for some reason the user chose to switch to my MS SQL instead of MySQL. So this eventually results in a summary that looks like this. So use MS SQL for data persistence with 2 tables, and the database, the total claims table should be updated via database trigger, and send a single email to both the employee and the finance team. So we don't want to maintain like a history of the interactions, but a summary of what happened. And ideally, where everything's generated by AI, you should be able to go with the requirements and the developer MD. You should be able to arrive at something that looks like the current version of the code based on just the 2 of them. Yeah, so that was about the development time. Now let's move on to natural language in code. So this is about the compile time and the runtime. Yeah, so natural language usage so far has been at development time and has mostly been outside the code. It doesn't get put in the programming artifacts except for the API documentation and the comment. It doesn't get put in the source files itself. So what if we can interleave natural language and code? So with runtime integration of LLMs, we do this to a certain extent, but we've tried to see if we can simplify that even further. So starting with compile time, we're exploring if we can specify the implementation of a function in natural language in the code itself, and then the compiler takes that and generates the code based on the requirements. It's like a copilot for a compiler. And it has quite close parallels in some aspects with literate programming, because when you look at the source code, you have an explanation of what the logic's supposed to do in natural language. So here I have another example in Ballerina. So we have country details and GDP per capita details. And we have a function, get countries with highest GDP per capita in continent. So here, if you see, there's no implementation of the function. We've just said it in natural language, filter the 10 countries with a population of at least 10 million with the highest GDP per capita in the given continent, and return the data. So the function, there's no implementation of the function. The compiler will take this at compile time and generate the code for you. So obviously this has potential to increase the readability and expressiveness, because it basically explains in natural language what you want to do. But obviously there's no human in the loop to review and accept this code. And it would work best with granular, unambiguous requirements. And again, it's up to the user to choose when to use this versus actually implement the code. The implementation could become a bit of a black box. Developers generally might tend to prefer, using a traditional Copilot, generating the code, and then committing it rather than using this way. But obviously, there's the advantage of it being more expressive and being able to explain it in natural language. Ballerina actually has a mechanism to preserve generated code per build. So we actually add the code into the project at compile time. The users can still look at the generated code per build, but obviously with each build, the generated code could change. So this is the code that's generated for that function. What happens is that function calls this function, so the user can still look at the code if they want to. So this is currently in experimental state. So obviously the generated code can change with each build, and it requires further consideration when it comes to maintenance, versioning, and so on. And there's no human in the loop to review and accept, right? And that could open up room for issues like related to security concerns. And so for this initial version, we've actually restricted it quite a bit. We've said you can't use like external organizations, just the Ballerina X organizations, which are all part of the Ballerina standard organizations. And then also the user's own organization, they can use modules from those. And also we don't allow it to include accessing like configurable variables, which generally tend to have confidential information. So if you want to use a connection, or if you want to use a connection to make a remote call to an external endpoint, then that connection should already be created. So we have some restrictions in place compared to like a traditional Copilot to avoid these concerns. Then we move on to runtime. So many languages and frameworks, including Ballerina, already support calling LLMs as part of the program logic. And now with that, it has expanded in a way the scope of the problems that we can solve. So if you take Ballerina, for example, it's a cloud-native integration-focused programming language. It does integration really well. But then there could be a requirement to maybe summarize or review natural language, which doesn't really cater to Ballerina's strengths. So by combining these two, we are able to actually expand the problem scope and address more problems than we would usually be able to with just the programming language. Again, the user decides what can be implemented in code versus what needs to be implemented using an LLM. So calling an LLM for like a chat completion use case generally includes initializing the client that can talk to the LLM, specifying an expected format for the response, making the actual call, and then once you get the content, passing it to the format the user expects in. This requires quite a bit of boilerplate code that could take away from the core task that's described in natural language. So for this, we'll take another example of like a blog site backend service. So I have a blog site, and there's two main operations: to submit a new post. And whenever a new post is submitted, we want to call an LLM to identify the most suitable category out of, say, 5 already predefined categories, and a rating out of 1 to 10. So this is specified in natural language, and it's obviously something an LLM is good at. And then there's like the integration part of it, where if there is a suitable category and the rating is above a predefined, say, 3, we accept the submission and persist the data. If not, we reject the post, and that's implemented entirely in the programming language. There's also another retrieval endpoint that retrieves based on categories sorted by what was the rating identified when the blog post is created. So that again is implemented entirely in the programming language, generated or implemented by the user. So this is an overview of the service. I'll move on to, so a brief overview of mapping JSON to Ballerina records, just so that it helps with the subsequent usage of records. So Ballerina knows JSON, and here it does also, while it can work directly with JSON, it can also map it to more stronger types. So here, if you look at ID, it's a string, so that's reflected in the employee record. So no one can go and change it to be an integer, for example. So these records can also be generated by via VS Code. So here for the blog site backend service, we have a blog and a review record. So the blog is basically what the user submits. We kept it simple, and you have title and content. And the review is basically the response that we expect from the LLM, the information that we expect. So it has string question mark suggested categories. String question mark basically means it can be null here. So it's string or null, suggested category, and the rating, integer rating out of 10. So the client initialization looks somewhat like this. You need the API keys. So this is for Azure OpenAI. So you need the API key, service URL, and then you initialize the client. The deployment ID is used later on. So this is what the code looks like, right? When you're using the generic client to do the review, get the response, and then be able to work with the review. So like Rania mentioned, it is in a way an integration problem, right? So after you do this call, it's not that you're going to do the call to the LLM and, okay, then forget about the data. You want to actually work with it. So this is why we're trying to bind it. So I'm not sure if you can see it, but at the very end, we have binding the JSON to the review type. So we've looked at this and we've tried to see how and if we can simplify it. So this is where we've introduced something called a natural function. So it's a special kind of function that can use a prompt associated with the function in a call to an LLM. So now, because it's a function, it can have a return type, and that return type can be used to generate a JSON schema to include in the call to the LLM to say, this is the expected response. It is the format for the expected response. And once the call is done and you get the response, we can use the relevant content, we can extract it and directly bind it to the type expected by the user. So this is a screenshot from the Ballerina integrator. Both the Ballerina and the Ballerina integrator support it. And now if you look at the function signature, we have blog as a parameter, and then you just have a text box where you can just write it in natural language. The implementation, you can write it in natural language. So this is what the code currently looks like. So we have the blog, and then we have the prompt, which you can, so we had categories as like a module level variable. So you can refer to any module level variables or any in-scope variables, like you have blog title, blog content here, and then it says returns review. So that will be used to generate the JSON schema in the call to the LLM. So we've tried to simplify everything that you need to do to basically call the LLM and then work with the response. So if you look at the actual resource now, where the post was happening, it's just a matter of calling this function with the blog. So with natural functions, we think it's easier to read and understand because it is basically written in natural language. And we've simplified it, we've tried and simplified it to keep the focus still on the natural language bits of it rather than the boilerplate code that comes with it. So we try to make it easier to work with the response and reduce the amount of code the user has to write. Obviously, the model still needs to be configured. So this also we've tried to simplify by making it something that's configurable. So if you're okay with a single model being applied to the entire project, you can configure it at module level. But if you still want like more fine-grained control over the model per function, there's a mechanism to do that also. You just need to add another parameter to the function and pass in the model. This also ensures that the schema and the expected type don't go out of sync because we basically use the expected type to generate the schema. So now this is a side-by-side comparison of what we had previously and what we have now. And we're continuing to work on how and if we can improve this experience to make it even more natural. Yeah, so reimagining the software development process with everything we've discussed. So we've gone from, we brought in business requirements into the project, and we already have the technical implementation documents, and it's possible to go from these two to the high-level language source code, which is like the Copilot use case, and to go from high-level language source code to the source code, which is the compile time prompt as code. So the user sees in the source code, but the user sees is basically the natural language description of what needs to be done, but that actually gets generated to the underlying source code at compile time. And then we have runtime prompt as code, which is what we discussed as natural functions, to be able to write natural language more naturally in the source code itself, and that gets translated into the runtime integration of an AI model. So current status, it's very early days. We've been working on this over the past couple of months, and but I'm happy to say that the current versions of both Ballerina and the Ballerina integrator support natural functions and the development time features. So we'd love for you to try it out and let us know if you have any feedback. So the compile time prompt as code, obviously there are the concerns that we discussed. So we're still experimenting with it. It's not available in the current version, but we might most probably add it in an upcoming version. So immediate future work. So we are looking to see if we can make natural functions even more first class. So we've modeled it as a function, but in fact, it is a special kind of function, right? And these integrations are here to stay. So it makes sense for the programming language to probably know about it. So we're continuing to work on identifying if there's a better way to do that and make the instructions be a part of the body itself. And we're also exploring extending natural functions to support tool calling and support for multimodal requirements. So we do have limited support for that at the moment, but we're continuing to improve that. And also, obviously, to scale natural programming to handle large-scale applications, because we look at the entire project, right? When we're checking for drift and so on. So there's a bit more work to do there also. But yeah, that's pretty much it.